All right, we're still dealing with the trigonometric identities right now. We're going to be talking specifically about co-functions. So what I'd like you to do is I would like you just to make a right triangle so you'll know exactly what we're talking about. Okay? So making a right triangle, I'm going to call this theta right here. We'll call this theta, make a right angle. And I want you to understand, whatever this angle is right here, it's going to be 90 degrees minus whatever, bless you, whatever theta is. So in a right triangle, if we go from this perspective called theta, then this angle is going to be 90 degrees minus theta. So for example, let's just pretend we know what theta is. What angle do you think that would be about? How many degrees? 40? All right. What do you think?
Yeah.
You want to do
about 37.
37. Okay. All right. All right. How about, you know what? Let's just call it 35. All right. 35. Now, if theta is 35, what would the measure of this angle be right in here? Yeah, you're right. All right. So Josiah, right here, this angle right here, 90 minus theta would equal 55 degrees. So what I'd like us to do is, for this particular problem, for our notes, I want you to pretend right now that in this right triangle that we just drew into your journal, that theta is about 35 degrees and this green angle is 55 degrees. So right now, you see his co-function identities? So watch this. In the calculator, watch this. Put the sine of theta, right? The sine of theta is going to equal the cosine, and you'll notice it says what? Pi over 2 minus theta. Now this is where students get confused. Pi over 2, what does that equal to in degrees? Pi over 2 is actually equal to 90 degrees. All right? So if you wanted to help you with your notes, everywhere it says pi over 2, what could you replace it with in degrees to help things 90 degrees. So right now, we are saying that what? The sine of 35 degrees should equal the cosine of what? 90 minus 35 degrees, which gets us what? 55 degrees. So let's get our calculators. Okay, get your calculators out. Let me show you that this is just an example. Okay, this is just an example. Okay, here we go. Take your calculators right now. Put them in degree mode. All right, and I want you guys to see that this is going to end up equaling this right here. This is which co-function are we practicing with right now? We're just practicing with this one right here. That's what we're working on. If you're wondering, what the heck are you doing? So let's review. Hold on, let me clear this out. Let me make sure my mode is in degree mode. Good. And then I'm going to say the sine of 35 degrees. I'm going to press enter and see what that equals. Ooh, that's an ugly number. All right, and hey, cosine of 55 degrees. Cross your fingers, roll the dice, drum roll, take drum roll. Come on, you have a desk right in front of you. There we go. It's the same thing. All right. Okay. Let's try another. Ooh, this says what? The tangent of theta has to equal the cotangent of pi over 2 minus theta. So here's what I'm going to go over here. The tangent of, what's our theta in this particular one? 35 degrees. What does that have to equal? That should equal the cotangent of what? 55 degrees. So how do I type this in the calculator? Let's see if we get this right. Here we go. Let's do the tangent of what? 35? Press enter. There's the tangent of 35. That's the approximate value for the tangent of 35. How do we do cotangent? What if I did alpha? Y equals enter. Then I put a 1 here. And underneath this I put a tangent. But I'm not going to type in 35. What am I going to type in? 55? I hope this is right. These are called, what are these called? No, it's not a yawn. They're not called yawns. Okay? Alright. They're called Co-function identities. Okay, so this is what I'm at. This is what I'm telling you right here. All right. So let's look at problem number 7. These are 2 examples. Let's look at problem number 7. Over here. Looking at problem number 7. Here we go. Ooh. All right. It says, if the cosine of theta equals 0.54, find the sine of theta minus pi over 2. So by the way, look at your co-function identity. What is the cosine of theta actually equal to? Look at your identities. Tell me what your cosine of theta is actually equal to. Oh, sorry. Let's go back. Cosine. Let's see here. Go down here. Ooh, what's the cosine of theta equal to? The sine of what? Pi over 2 minus theta. So we'll go back. It's equal to pi over 2 minus theta. So right now, look at our problem and look at what we're dealing with here. What's different? Nothing. They switched them, right? What happens if we switch them? What if the cosine of theta should equal the sine of 90 degrees minus theta? Then what's going to happen? I want you to understand this. The cosine of theta will equal this will end up becoming negative if you do what? If you switch theta and 90. It'll become negative. So watch what happens here. Right now, I want you guys to understand that. I'll show you guys the calculator. Let's pretend that we'll find what theta is. So right now, if you guys would, could you guys please find the inverse of cosine and put 0.54 so we can figure out what theta is? Let's find out what theta is. Okay. So go to your calculator, hit second cosine. The inverse of cosine, we're going to have a 0.54. And what's that going to find us the measure of? It's going to find us the measure of theta. So what's the measure of theta? About how many degrees? 57.3 degrees. Okay? So if I typed in the sine of 90 minus 57.3 degrees, look what that equals. What's that equal to? 0.54. Well, what happens if I do what the problem asked us to do, which was take theta, which was, well, what is our theta? 57.3 degrees, that's our theta. And what happens if I take away 90 degrees? What does our answer end up becoming? Negative 0.54. So if you switch them, if you switch theta and 90, what happens to your answer? It becomes not positive, it becomes negative. So check this out. If the cosine of theta equals the sine of pi over 2, also known as 90 degrees minus theta, then our answer right here, theta was what? 57.3 degrees. I want you to understand that the sine of theta minus pi over 2 is simply negative 0.54. So if these end up becoming what? If these end up becoming switched, because normally it's what? Pi over 2 minus theta. If you look at all of the cofunctions, what's it typically? It's 90 minus theta, 90 minus theta, 90 minus theta. So if they switch it, what happens? The answer just becomes negative. That's it. All right? So over here. Okay, if we look at this one right here, could somebody tell me what the cotangent of x equals as its original cofunction? What's the original cofunction of the cotangent of x? Look at your chart. The cotangent of x is equal to what? So look at your chart. The tangent of what? Pi over 2 minus theta, right? So instead of theta, they're using what? They're using x. If you look at the co-function chart, that should be in your journal. All right. This is the original co-function. The cotangent of x equals, here's another way of saying it, ready? The cotangent of theta equals the tangent of 90 degrees minus theta. That's another way of looking at it. Well, what's happened here? It's been what? It's been switched. So if it's been switched, then if it says the cotangent of x equals negative 0.18, and it says find the tangent of not pi over 2 minus x, because by the way, pi over 2 minus x would equal the same number. Okay, would equal the same number. It says, what's the what? X minus pi over 2. What's going to happen to this answer over here? It's going to become the opposite, to the positive. All right? So I'm going to show you guys right now. I'm going to show you how this works in the calculator. Okay? That's the answer. Yeah, it just becomes the opposite. All right? So understand that whenever you get, yes, sir. So, one second. Here's another way of looking at it, right? The cotangent of theta will equal the negative tangent of theta minus 90. So if these are equal to each other, then this one will equal the negative version of this one. If these switch, what happens? It becomes negative. That's another way of looking at it. Okay? All right. Now, moving on.
I like number 13.
You like number 13? All right, we'll get down to Raymond and Delaney here in a little bit. All right, number 13. All right. So everybody, what I want you guys to do is I want you guys right above here in your journals. I want you guys to write the Pythagorean identities. So I'm going to label all three of the Pythagorean identities. So I want us to have these as we're working on them. Okay. The Pythagorean identities are sine squared theta plus cosine squared theta will always equal 1. That's one of the Pythagorean identities. So write that down in your journal. Okay? Pythagorean identities. Okay? The other Pythagorean identity is the tangent squared theta plus 1 will always equal secant squared theta. And the last one that we're going to write right up here, okay, is going to be the cotangent squared theta plus 1 plus 1 will always equal the cosecant squared theta. Before we go ahead and start working through these problems, we're going to investigate. All right. So right now, Josiah, we use 35 and 50, right? 35, 55. Okay. For theta. So right now, we're just going to choose some random numbers for theta. All right. So right now, what do you want theta to equal? How many degrees? What was that?
26.67.
I'm
just kidding. 25.
25. Okay. So theta is 25 degrees. We're going to use just 25 degrees in all of these, okay? All right, so right now, I want you guys to get your calculators, and we're going to investigate this, we're going to investigate this, and all of these, okay? So here we go. Get your calculator. I want you to type in sine, okay? We're going to type in 25, but how do I square the sine of 25? This is where students, one second. All right, so we're going to go all the way over here, everybody. Go all the way over here. I want you to hit second insert. I want you to open up a parentheses. So we're going to go all the way over here. I'm going to close the parentheses, and I'm going to square it. So this is sine squared theta. And I'm going to say plus, open parentheses, cosine of 25 degrees, and I'm going to square it. And if this Pythagorean identity is true, All right? If this is true, what should all of this equal? What is the sine squared theta plus the cosine squared theta have to equal? 1. So if this is true, it should equal a 1, and it equals 1. All right. Now, by the way, let me show you a little bit easier way of why this is true, okay? Let's just use an easier triangle, all right? Let's use, you've probably seen this before, the 30, 60, 90, right? This side is 1, this side is radical 3, this side is a 2, okay? So if we just use the properties of a 30, 60, 90, sometimes it's a little bit easier to understand why this is true. So from this perspective, Josiah, what would be the sine of 60 degrees? What is the sine of 60 degrees? What's the opposite side?
Radical.
Very good. And what is the hypotenuse? 2. Okay. So let's look at the cosine. Ready? What is the cosine of 60 degrees? What's the cosine? What's the adjacent side? 1. And what's the hypotenuse? 2. Okay. So this is the sine of 60 degrees. This is the cosine of 60 degrees. Right? So watch what happens. When I do radical 3 over 2 squared plus 1 over 2 squared. This is the sine of 60. This is the cosine of 60. What is that going to equal? If I do it in the calculator, it should equal a 1. Why does it equal a 1? What is radical 3 times radical 3? 3. What is 2 times 2? 4. What is a half plus a half? 1. What is 3/4 plus 1/4? 4, which is a 1. So this is a Pythagorean identity. Okay? So by the way, you know what we're going to do? We're going to use this right here to show you all the Pythagorean identities. Okay? So right now, honestly, this would probably be the best thing for you to put into your journal. You already have this. This is an example of what? Sine squared theta plus cosine squared theta equals 1. Right here, we're going to do the next one. Kayla, can you tell me the next Pythagorean identity that you have on your paper? Go. Okay, cotangent squared theta plus 1. Secant squared theta. Okay. Oh, cosecant. All right. So right now, would you guys look at the cotangent of 60 degrees? Let's look at our cotangent of 60 degrees. What's the cotangent equal to? What's the relationship? Cotangent. Nope. Adjacent over. So from 60 degrees, what's my adjacent side? What's my opposite side? So right now it's what? It's 1 over a radical 3. We don't have to worry about. We have to typically we'd rationalize it. And what would that equal? That would equal 3 radical 3 over 3. All right? So right now, that's the cotangent. All right? So if we square that, right? If we square that, what does that become? What is 1 radical 3? What does that become if we square? Yes, that becomes 1 over 3. Now if we add 1 to that, that becomes what? 1 and a third, which is 4 over 3. So cosecant squared. Cosecant squared. What's the relationship of cosecant of 60 degrees? What's our cosecant? What does that compare? Yep. Hypotenuse over what? Over the opposite. Okay? What is our hypotenuse over here equal to? 2. Equal to 2. What is our opposite side equal to? It's over what? Radical 3. So watch what happens if we square that. If I take 2, I know we don't have to rationalize it right now, because what are we going to do? We're going to square it. What does that become? 4 over 3. So we just figured out that the cotangent squared of theta plus 1 is definitely equal to the cosecant squared of theta using what? The properties of a 30, 60, 90. So I'm just showing you that these are indeed true if you use the properties of 3069. All right, now that I've totally bored you guys, what we're going to do is we're going to go and do some problems so that you guys can actually wake back up. So here we go. We are going to simplify this expression right here, okay? We're going to simplify this expression. So here's what you have. You have the cosine of x plus the sine of x times the tangent of x. So go ahead and put number 9 into your journal. Show you guys how to work it step by step all the way through. All right, right up here, the information we're going to need to know is you need to know that the tangent of x will always equal the sine of x over the cosine of x. All right? And if you look at your paper of the notes that you have in your journal, this is part of the quotient identities. All right? That is at the top of your paper. All right? It's a quotient identity. So what we're going to do, we're going to take this guy right here. And where are you going to substitute this guy? You're going to substitute that guy right here. All right? So, let's see what it looks like. We've got what? We've got a cosine of x plus the sine of x times what? Times the times the sine of x over the cosine of x. So I'm just letting it snug loose box. So by the way, what are we going to be multiplying? Can we multiply the sine of x times the sine of x?
Yeah.
What does that become?
Squared.
Very good. So this becomes, right now here's what we have. We have the cosine of x, and I'm going to put this over a 1. And I'm going to add the sine squared of x over the cosine of x. So I just want you to know that the product, if you're wondering what the heck I just did, what did I multiply together? I multiplied the sine of x times the sine of x, and what did that become? The sine squared of x. That's what you get. Now, when you're adding fractions together, what do you need to have in order to add fractions together? Common denominator. Do we have a common denominator? No. So, no, we're not going to cross multiply. But what does this denominator need that it does not have? It needs to have the cosine of x. So what you're going to do is you're going to take this and you're going to multiply it by the cosine of x times the cosine of x. Huh. So what are we going to have in the numerator right here? Cosine squared of x over a what? Cosine of x plus, what do we have over here, everybody? On the right side we have a what? Sine squared of x over a cosine, cosine of x. By the way, what is our common denominator? So that goes right here. Now, if we only knew what the cosine squared of x plus the sine squared of x would always equal, that sure would be helpful. Does anybody know, let's go back here, what the cosine squared of x plus the sine squared of x will always equal? 1. So what are you going to do on this problem? You're going to put a 1 right there. By the way, your answer is 1 over the cosine of x. But wait, what is equal to 1 over the cosine of x? Let's go to your original chart and see if we can find what 1 over the cosine of x is equal to. Let's see here, 1 over the cosine, 1 over the cosine, 1 over the cosine. What's it equal to? Secant. That's right there, the secant of theta. So your final answer is 4. Aha! The final answer of all of this, if you got 1 over the cosine of x, the final answer is, that's it. So what is this, by the way, what's this problem ask you to do? Simplify. Would you agree this is a heck of a lot more simplified than all of this?
Yes, sir.
Okay? So, we're going to keep moving forward. All right. Problem number 10. What is the cotangent of A all by itself equal? By the way, could you guys look at your quotient identities? What's the cotangent of A equal to? Look at your quotient. Top right-hand corner of your page. Top right-hand corner. Quotient identities. What is the cotangent equal to?
Cosine of the sine.
Ah, so it's the cosine of A over the sine of A. Okay, what's the tangent of A? What's the quotient identity? Tell me what that's equal to. Sine of A over the what? Cosine of A. How do you guys divide fractions? You multiply by their reciprocal. So right now, what I'm going to do, I have this divided by what? This. So here's what I have. I've got the cosine of A over the sine of A, and here I have the what? I have the sine of A over the cosine of A. So what we have to do is we have to multiply both this and this by the what? By the reciprocal. So what's the reciprocal of this? The cosine of A over sine of A. And what's the reciprocal of this one? Cosine of A, right? Over the sine of A. Alright? So, if this right here, if we have the cotangent of A divided by the tangent of A, we have to multiply it by its reciprocal. So what happens here? These cancel out, these cancel out. Okay? So what do you guys have? What's the cosine times the cosine? That becomes the what? Cosine squared of A. Over the sine squared. Now, Josiah, do you see the cosine squared of A over the sine squared of A? By the way, which one does that line up with better? Cotangent or tangent? Which would you think it lines up with? Cotangent. By the way, this right here is actually equal to the cotangent squared of A. And that's the most simplified version that you can get. So once I got this, once I realized it was the cosine squared of A over the sine squared of A, then I went right back up here and realized, oh, that becomes the cotangent squared of A. All right, now I'm going to start the next problem, and I'm going to see if you guys can go ahead and see if you guys can complete. Okay? So here's what I'd like you to do. Last problem we're going to work on right here. Does anybody see any common factors in this particular problem right here? Any common factors?
Cosine squared.
Cosine squared. So take out cosine squared. Okay? So we're going to take out cosine squared of theta right here. We're going to open parentheses. We're going to write sine squared of theta minus 1. That's what I want you guys to write there. Write that down. Cosine squared of, by the way, this times this equals this one right here. This times this equals that one right there. Okay? Or it's the, where we factor it out. So yes, you boil it back in and get back to where you were. Now, write this down. Sine squared of theta plus cosine squared of theta equals a 1. Now, if I take away, if I take away a sine squared of theta, and I take away a sine squared of theta, what is the cosine squared of theta equal to? It's equal to 1 minus the sine squared of theta. So what is cosine squared of theta always equal to? 1 minus sine squared theta. Do we have a 1 minus sine squared theta?
Well, no.
We have a sine squared theta minus 1. So what do you think happens when things get reversed? What do you think happens when things get reversed? What it becomes the opposite. So if one of them was positive, now it becomes negative.
We can plug in.
So what do you think? What do you think the sine squared of theta minus 1 actually is also equal to? If 1 minus sine squared theta equals a positive.
So it's the negative cosine squared theta.
That's right. So you are correct that this right here is equal to, and we have that, and guess what? We're going to plug that in where? Right in here. We're going to plug that in. So, Josiah, we're going to take cosine squared theta, and we're going to multiply that by a negative cosine squared theta. So your final answer is a negative cosine to the power of 4. Theta. That's as simplified as it gets. Which Pythagorean identity did I use? The most common one, which was sine squared theta plus cosine squared theta equals 1. All right. I want you guys to do that last problem. Try to break it down as much as you can. Find some things that it lines up with. Good luck.